Welcome to AWS Autoscaling Service and Architecture. In this section, we'll talk about autoscaling. We'll talk about some of the features of autoscaling, some of the architecture decisions we need to make when we're using autoscaling. We'll understand how we can use autoscaling to do our automated capacity planning. There are some terminology about autoscaling we need to understand. And we'll figure out how autoscaling works together with some of the other AWS services such as CloudWatch, SQS, Elastic Load Balancers, and Simple Notification Service, SNS. Traditionally, it's been a challenge balancing the requirements of the application as far as the load is concerned, how much load or traffic we should expect or we are expecting for that application, and what kind of capacity we should plan for that application. Traditionally, we have done IT planning or IT capacity planning. In most of it is guesswork. So we are expecting this dashed line, the gray line is the expected traffic or the predicted traffic, and we invest, we do upfront investment of our hardware, our infrastructure, and then when we hit that number, when our expected traffic meets the capacity that we are deployed for that application, we go ahead and bump up the hardware, we upgrade it, we add more servers, and then let it run for a few more days or few more weeks. And then when we meet that point, we add additional capacity, additional server capacity. We may increase memory, we may add more servers, and so on, so forth. What happens in reality is, this is the investment that you're making. The blue line is the investment you're making, the fixed capacity investment you're making, and the red line is the actual demand for your application. So over a period of time, as you can see, there's a gap between the actual demand and your server capacity. So the gray shaded area is the times when you had excess capacity. So you're essentially wasting your server capacity because there's not that much demand for that application. You have invested excess resources, you allocated excess resources for that application, and all this space over here, all that capacity is wasted. So this is the reality, this is the problem number one of traditional capacity planning. The second problem, of course, is major one. When we do get that spike, when we get those users, our capacity that we planned or deployed for that application is not able to keep up with the demand. So we are either turning away the users, or they're getting a bad experience because there's unexpected spikes and the capacity that we have allocated for that application is not able to keep up with it. So this is problem number two in traditional capacity planning. So what we want is what we call an ideal capacity planning. Over a period of time, we want the number of servers that our application is consuming based on the actual demand. The capacity keeps up with the demand curve, and then when the demand keeps falling off, either because of the end of the day or end of the week, or during the holiday season when we don't need enough capacity, the number of servers that the application is using keeps on going down until we use a bare minimum of servers to keep up the application. So as you can see, the server capacity is keeping up with the demand curve. So this is what we want to follow in an ideal capacity planning model. So when we use autoscaling, we get several benefits right out of the box. The first thing we do is we scale out or scale up our capacity automatically when the demand increases. There's no manual intervention. Nobody has to watch it when the capacity goes up. So nobody has to add server capacity. And conversely, when the demand decreases, we want to scale down or remove the additional capacity that we allocated. It allows us to, autoscaling essentially allows you to start or terminate instances based on certain conditions, and we can configure what those conditions are, and we can configure how many instances to start or how many instances to stop when those conditions are met. You can make this scaling decision based on CloudWatch metrics. The other benefits or other feature of autoscaling that we will see is we can configure our application to make sure there's enough or minimum number of instances that are running all the time. So we can say make sure our instance is running with 4 instances all the time. And if for some reason one of the instance crashes or one of the instance it becomes unavailable, autoscaling starts another instance of the same AMI to replace the failed nodes. So this is a very good feature of autoscaling, which monitors our instances, and if something happens to those instances, they get replaced automatically. We can scale based on certain events that are happening in our environment. Let's say our CPU goes up, or the number of requests go up, or the number of jobs that we need to process has gone up. So based on those conditions, we can scale up our infrastructure. So autoscaling in general is good pattern for web service, web layer, for media transcoders and batch processing jobs. So if you think about for a second about media transcoders, so these are the services that you may upload a photo or a video, and then they are transcoding that video to different formats, to different resolutions. When they are doing that, the number of jobs keeps varying throughout the day. So those service providers can then use autoscaling to determine how many instances to run at that particular point of time. The same thing for batch processing jobs. When you have a job that runs, let's say at the end of the month, and during the entire month, you don't need excess capacity. You need that capacity only when the batch jobs are being run. So this is ideal for those use cases. So the benefit of autoscaling is it helps us meet our business needs, but at the same time it lets us save cost by turning off instances we don't need. So let's say we want to add capacity when the CPU of our instances go over 70%. So in that case, what we want to configure is we want to add 2 additional servers when our CPU goes over 70%. And finally, we can configure autoscaling to maintain a minimum number of instances in our applications. So if one of the instance crashes, autoscaling will automatically start that instance and replace the failed instance. So this is a separate feature. So let's take a look at autoscaling architecture. So the AWS engineer or AWS user essentially creates something called a launch configuration, which specifies the type of instance we want to use, the operating system or the AMI that we want to use, the SSH key pair, and the security group we want to use when we are starting these instances. And that launch configuration is used by this autoscaling group. In addition to the launch configuration, we need to define what's called scaling policies, which are scaling policies are actions to take for adding our instances or increasing the capacity or decreasing the capacity. Then we configure CloudWatch to watch any kind of metrics in our instances. So let's say we want to monitor the CPU of all these instances. Let's say a threshold of 80%. And if our CPU goes above the threshold, the CloudWatch sends an alarm or alert to our scaling policies, and then the autoscaling group gets informed of that event. And the autoscaling group in that case will either add the capacity or remove the capacity, and then we might configure the autoscaling group to send a notification to the engineer, to the cloud architect. So this is how we configure autoscaling for our application. Let's talk about some of the autoscaling concepts. The first concept we want to talk about is called cooldown period. The cooldown period essentially specifies how long should we wait between each autoscaling action. So let's say we received an alert, we increased the capacity from 2 to 4, and immediately we received another alert to another scale up event. Do we want to add more capacity at this time, or do we want to wait for a few seconds or few minutes before going from 4 to 6? Okay. So that's the question that's answered by the cooldown period. So essentially cooldown period is saying if you just took an action, if you just added additional capacity to the infrastructure, wait for a few minutes before you continue adding additional capacity. So that's the cooldown period. The scale up policy, like the name suggests, specifies under which conditions, under what condition are we going to add instances and how many of them are we adding. The scale down policy, on the other hand, specifies under which conditions we are removing those instances and how many at a time we are removing. Next, we want to talk about launch configuration. Launch configuration specifies the EC2 instance type, whether we want to have a large instance, a small instance, or a micro instance, and the security group that we want those instances to use, and the AMI or the operating system we want to use. In addition, we need to specify the SSH key pair we want our EC2 instances to use when they are started by autoscaling. The next step in the process is we have to create an autoscaling group, which essentially uses the launch configuration we created in the prior step. In addition, it specifies the scaling policies that we talked in the previous slide, the scale up policy and the scale down policy. And you can also specify the minimum or maximum instances that we need for autoscaling group. Optionally, we can specify notification. We want to get notified of any event or any action that's taken by autoscaling. So we can use another Amazon service called Simple Notification Service, and we can either get a text alert or an email alert when any of these actions takes place in the autoscaling configuration. So autoscaling integrates with other AWS services. Obviously, it integrates with EC2. It starts and terminates EC2 instances when certain conditions are met. It integrates with elastic load balancers. So when autoscaling starts new instances, they can be automatically added or removed from elastic load balancers. It integrates closely with CloudWatch, and CloudWatch is a service that monitors our instances, and if a condition is met, it sends an alert for those scale up and scale down actions. And we talked about Simple Notification Service SNS. We can optionally receive notification of the scaling events or scaling actions. So in summary, we talked about autoscaling, we talked about the features of autoscaling, we understand autoscaling architecture, we understand how to set up autoscaling for our infrastructure, we understand the challenges of capacity planning, the traditional capacity planning, and now we know how autoscaling can help us achieve some of those capacity planning goals. We understand the terminology associated with autoscaling, essentially the scale up policies, the scale down policies, the cooldown period, the launch configuration, and then the autoscaling group. Now we understand how autoscaling works closely with CloudWatch service, how it integrates with ELB service, the elastic load balance service, and how we can get notified from autoscaling when an event happens or when an action is taken by autoscaling.